Hello, my name is Drew Washington, and I'm doing my presentation on beta thalassemia. So, what is beta thalassemia? Beta thalassemia is a genetic disease in the family of hemoglobin disorders. It's a disease that occurs when there is a reduction in the normal amount of hemoglobin in the blood, which means that the red blood cells cannot produce in the correct way. This can lead to anemia, which is very serious because hemoglobin is responsible for carrying oxygen throughout the rest of the body. So, what is the cause of beta thalassemia? So, the gene responsible for beta thalassemia is called the HBB gene. The typical function of this gene is to facilitate the production of beta globin, which is a key part of hemoglobin. A hemoglobin typically consists of 2 alpha globins and 2 beta globins. In beta thalassemia, either one or both of the beta globins will be affected because either one or both of the HBB genes can be mutated, which directly affects the production of hemoglobin. So there are 2 different types of beta thalassemia, beta thalassemia major and beta thalassemia minor. So beta thalassemia major occurs when both of the HBB genes are fully mutated, and this is the most severe case of the disorder. With the 2 mutations, there's just such a decrease in the amount of hemoglobins. And then with the beta thalassemia minor, this occurs when only one of the HBB genes is mutated. And this is a less severe case of anemia. And then within beta thalassemia minor, there are 2 subdivisions called thalassemia minima and thalassemia intermedia. So thalassemia minima is you really don't have any symptoms. You're essentially asymptomatic. And then for thalassemia intermedia, you have kind of just a more mild case of anemia. So who gets beta thalassemia? So beta thalassemia is a common blood disorder in certain regions of the world, specifically in the Mediterranean countries, Northern Africa, the Middle East, Central Asia, and Southeast Asia. So although even though if you live in one of these regions, you're only at risk if one of your parents has a history of beta thalassemia, so then it can be passed to you. Mode of inheritance. So this is an autosomal recessive disorder, which means that the parents who are carrying the gene won't have any signs or symptoms of it. They will only appear in the offspring. So, on rare occurrences, beta thalassemia can be autosomal dominant, which means that even if only one copy of the HBB gene is mutated, it can still cause symptoms of beta thalassemia. So, signs and symptoms. So, essentially, the first signs and symptoms appear within the first 2 years of life. So, for beta thalassemia major, the most common symptoms are fatigue, pale skin, jaundice, loss of appetite, and then when it's not treated, it can even cause enlargement of organs such as the liver, heart, or spleen. For beta thalassemia minor, some of the common symptoms are fatigue, pale skin, brittle bones, essentially a lot of the same symptoms as the major, but just less severe. And then As I mentioned previously, for the thalassemia minima, you're essentially asymptomatic. So here is a pedigree pattern that I created to kind of show how beta thalassemia could potentially be passed through 3 generations. So here in this pedigree, the shaded shapes are afflicted people. The shapes with circles are carriers, and the shapes with nothing are unaffected. So here I started with a afflicted male with a carrier female. They had 4 children, 2 afflicted, 2 carriers. Each of them then went on to have children. So in the first set, you can see the John and Deborah. They had 1 afflicted, 2 carriers, 1 unaffected, based on their genotypes. That was their percentages that they could have. And then the second, Mike and Robin, they had 2 carrier children based on their genotypes. Maria and Tony had 2 carriers based on their genotypes. And then lastly, Emma and Nate had 2 afflicted and 2 carriers based on their genotype. So again, this is kind of just an example of how beta thalassemia could be passed down based on the genotypes that I provided here. So genetic testing. So genetic testing for beta thalassemia is done by detecting whether or not a person has the HBB gene mutation. And there are 3 options for this. You can do a blood sample. You can do an oral swab of your mouth to get your saliva, or you can do a prenatal test for your baby and get an amniotic fluid sample. So genetic testing is not mandatory for anyone, but it is really highly recommended for those who live in those areas that I mentioned previously. More specifically, people who have a family history or those who are planning to have children, because it's very important to be able to have the proper treatments since this disease can be severe in the major cases. Treatment. So currently, the treatment plan for beta thalassemia is a blood transfusion. This is a good treatment because it increases the amount of normal red blood cells with normal functioning hemoglobin in your body. And this is for the more major cases. And then for the more minor cases, to kind of help combat anemia or just, treat it, it's recommended to take like a vitamin B supplement. So current beta thalassemia studies. So in addition to the blood transfusions, there are a couple case studies with the CRISPR gene that are being conducted. So CRISPR stands for clustered regularly interspaced short palindromic repeats. And this is done by using a small strand of RNA to direct the Cas9 gene enzyme to a site in the genome that has a similar sequence. The Cas9 enzyme works to cut both the DNA helices, which allow the sequences to be altered. So in short, this kind of allows for gene modification with people with a beta thalassemia. And there is a lot of controversy around this, around the whole CRISPR gene therapy. So I don't really believe that this will be a solid, reliable treatment in the future. So for now, it's just blood transfusions. Here are my references, and thank you so much for listening.